Okay, so today we have Codeforces educational round. I believe we are a couple of minutes late because I was sleeping, but it's not a big deal. I still hope we can perform just nice. So let's try. Okay. We will also use, some sort of code editor. Okay, so regular bracket sequence. Bracket sequence is called regular if it's possible to obtain correct arithmetic expression. Yeah, we know. So it's kind of balanced, right? So we never have more closed brackets than open brackets, and we at the very end we have equal number of them. Okay, we're given a sequence S of n characters. Okay, so we know some characters and we do not know other characters. Or actually, we know only one open bracket and only one closed bracket. Okay. And we got to replace unknown characters with brackets. Determine if it's possible to obtain correct sequence. Okay, so clearly it is impossible if the length is odd, right? Let me say it somewhere. Well, and we have a lot of test cases, so we'll need a sort of fast input output, right? Just like that. And also like that. For those of you who don't know, these three lines correspond to fast input output. They turn off the synchronization between modern C++ way of reading input, which is, of course, is input streams, right? And output streams. And so this turns off the synchronization between modern way and an old way of printf, write scanf, which can be sometimes slow if you have to sync these two ways of input all the time. Okay. Now we need a number of test cases. We want to process them one by one. We don't care about the number of test cases, so I will use a common idiom. We now can read the string. Well, it doesn't really matter whether we define our string here or probably here. Sometimes we want to save memory and we define string here, but we don't really care because our strings are short. So we can just define everything where we need it. Okay, so the first property that a correct bracket sequence should have is it must have even length. If the length is odd, and we can check if something is odd by taking bitwise AND with 1, because bitwise AND with 1 will effectively ignore all the bits except the least significant one. So yeah, it checks if the last bit of length is 1 or 0. If it's 1, then the number is odd. If it's 0, then the number is even. If it's odd, we can immediately print null. Else we have to sync. Let me sync. I feel like the only thing that can fail us, right, is if we have first closing bracket and last opening bracket, because these two obviously cannot be fixed. So let's check against this as well. If the length is right, is what? Or S0. And I think I will grab length into a variable because I probably will use it several more times. So if length is odd, just to make sure I'm not sure which operators have what priority here. So if the first character is closing bracket, and obviously initial balance is -1, so we cannot do anything about it. There will be no parent bracket for the first closing one. And we also don't like the case when the last bracket is opening. And I believe that that's it. Let me think about it. So we would like some sort of proof. For that, we obviously need some sort of drawing, right? So we got a couple of positions where we can use some insert characters. You know that somewhere here we can have, yeah, so that's our entire string. Somewhere here we have closing bracket, somewhere here we have opening bracket. Then show we have some space between them. If something like this happens, what can we say? Like, if we can pair each of them immediately, right? So if there are at least 2 empty spaces next to them, then we are pretty much done, right? Because we then just take any valid sequence here and insert these 2 in a valid sequence, it will remain a valid sequence. If we cannot, however, do this, it means that let there be d empty spaces between them. If d is greater than equal than 2, then we can just pair them each with its own bracket. If d equals to 0, it means that they are already paired. We can remove them, construct any valid RBS, and insert. It will never break anything. The only remaining case is d equals 1. In this case, the entire length is even, which means that we have some space either there or there. If we have some space there, then we can insert closing parentheses there, opening here, remove this and complete the construction. If we don't have any space there, then we can insert like this and complete the construction. So I believe these three conditions are necessary and sufficient for string to be constructible. So we need to length. First is not closing, last is not opening. Yeah, I didn't think before the contest, so we will have to test our solutions in some sort of online compiling environment. Yeah, no, definitely not that. Well, it looks reasonable. I mean, we can try. Definitely not that. But we can try that. Yeah, and we spend a lot of time explaining, but it's okay. Good. So obviously that problem was easy. Let me copy something for the next problem. Okay. Red and blue. Monocarp, for those of you who don't know, it's a very famous character of all these kinds of problems. So yeah, he had a sequence consisting of n plus m integers. He painted elements into two colors, red and blue, and elements were red and m elements are blue. After the painting, he written red and blue sequences, right? Right. Okay, the original sequence was lost. Okay, so he wants to restore. Okay, there are multiple ways to restore. He wants to choose store the maximize the value of. Okay, so he wants the array that is lexicographically largest, which is understandable. So we will need obviously a vector. And I know that you can write something like include bits std++.h and don't care about what you include and what you don't include. I don't like it because I like being explicit. I know it says sometime, but obviously, I mean, how many times in a contest you write include statement? What, like 10, 20? 20 lines seems a lot of time, and I don't think so. Okay. So there are again several test cases, and the shorter way to write that for loop would be like that. And I also know that you can write using namespaces D. I already explained the reasons why I don't like it. It saves not all that much time, but your code looks better with STD. It's my personal belief. Okay. Int n is the size of the array, right? Or actually, okay. We have two arrays. So we are currently simply reading input, and it would be better if we could separate this input reading into its own function, but at the current moment I don't necessarily care, because I mean it's contest anyway, so let's leave it like this for now. We also want an output array of size n plus m, and what we will have, or actually we don't need output because we can construct it along the way. Right. Okay, okay. Wait a second. He wants to maximize that value. So he don't necessarily wants to maximize array lexicographically, but I believe it's the same thing. Like if he maximizes the prefixes, right, then there's only one way to do it. It just always take max elements, no? Or am I terribly wrong? No, okay. No. It's a different thing, of course. Yeah, let me write something. Let me write after I scroll to the sample. Okay. Okay. In the first case, we have something like 6 minus 5, 7 minus 3, 2, 3 minus 1. So this is red, this is blue. I don't want to switch between colors all the time. So everything will be red for now. Okay, so I believe that at any given prefix, right, we want to maximize the prefix sum. So any given prefix consists of some prefix of R and some prefix of B. And we don't necessarily care in which order these two guys appear. So we can find max prefix of R, or probably an empty prefix if all elements are negative. Or should I say all prefix sums are negative. Then we can just write that part. And we find the max prefix. The prefix is maximal sum of second array. Added here. It's R prefix and B prefix. R prefix, this is B prefix. And we have some sort of R suffix. And B suffix, we don't necessarily care, we just want to, we don't even want to append them. Yeah, we don't need to construct the array, we can just find maximal prefix sum of R and maximum prefix sum of B and add these two together. Okay, sounds very simple. I'm actually interested. Partial sum is most probably in algorithm. I can actually check and reference. And probably the only reasonable usage of algorithm of include bits std++.h is when we don't remember where the function you want to use is, but usually if you don't, it's usually algorithm. I see. Okay, so I think you can rewrite the current array, but we're not going to do that. We create prefix. Okay, prefix sum of red numbers. You can also do the same thing for blue numbers. And then we want to yeah, let me be explicit. I mean, for the previous names, they were present in the problem statement. I'm not sure if it's a good practice to change them, even if it results in more readable names. So prefix sums, red prefix sums, okay. Max red prefix sum gets std max of 0 and std max element. Or actually, you can do something like this. So you start with 0, then you use back inserter, and then you can simply write std max element of red prefix sums begin, red prefix sums end. So we include empty prefix by initializing prefix sums with 1 0. In the second part, we want blue prefix sums. Okay. Back inserter. And I also think that std back inserter is in iterator, right? In iterator header. So I want to include this as well. We now take max blue prefix sum. Or getting close to line limit, whatever. And I believe that we want to output simply the sum of this, right? Balloon. Blue, of course. Yeah, let me check whether this works or not. We should get 131300. And we get compile error, which is expected. Am I terribly wrong about something? Or is it not algorithm? Numeric, oh, whatever. That was kind of unexpected. But useful to know, you know. Yeah, because I'm a fool and I iterated over an integer. You, of course, want to iterate over array. 131300, let's go. Submit. It would be actually interesting. Okay. Oh, because max element is in algorithm. Whatever. Compile error is not runtime, so you don't get any. Anything bad for it? Okay, we got another accepted. Not very impressive so far. And we might kind of slow, but it's okay. Building a fence, yeah, it will be another problem with test cases. So you can actually start with a template like this, right? It's an educational run, right? So there will be some kind of testing phase afterwards. So we cannot be actually already 100% sure that we get correct solutions. Just keep in mind. Okay. So we want to build a fence, presumably a wall with Mexico. I don't know. It will consist of n equal sections. All sections have a width equal to 1 and height equal to k. Okay. We'll place all sections in one line side by side. Fortunately, the ground beneath the fence is not flat. Okay. Yeah. explicitly we can say that the ground level under case is I section is equal to height I, right? So I suppose that gray represents ground, and consecutive sections should have a common side of length at least one. Yeah, so what they say is that it is prohibited to have fence boundary or something like that, right? So there's no, it's not really it's not really a fence, right? Because you can stand here and step to the other side. It should be a fence. First and last sections should stand on the corresponding ground levels. How about these guys? Nothing about them. So the section between may be either on the ground level or higher, but not higher than k minus 1 from the ground HE. Okay, so effectively we want to place, this is a terrible legend for a problem. What kind of fence is it? I believe what they wanted to say is that you have planks of a height from k to 2k not inclusive, right? So you kind of take a full plank and take a part of it. So I don't know, you cut it into two and then use the half of it or some other part. That way it would be a way more reasonable problem statement. And we are asked if it's possible to build a fence that meets all the rules. Okay. Okay. I think what we can do, I mean, at any point in time, we have lowest possible position and highest possible position. So lowest position is like this, highest position is like this. Can't be like this because then there will be no common side lengths, right? Lowest possible position is at least the ground. Highest possible position is at most previous height minus 1. So we maintain such an interval. In this case, for example, these two guys, they agree. So we have only one pass through this peak. Then also lowest common position cannot be lower than chi minus 1 from previous, right? Because then there will be no point if the lower bound was here. And the upper bound, I think, and the upper is not higher than chi minus 1 over the ground. And what we really want to check is that if in the last place it agrees. So if it is possible to get to the bottom. Yeah, I think this is what we want to check. So we will have two variables. Well, first we will read the input, right? So we have n and k, which is the length of the fence and the height of one section. And we also have a vector of heights. Again, we need vector. and then we read them with a simple auto-reference loop, very useful in case you don't know about it yet. Okay. The sum of n over test cases doesn't exceed 2 times 10 to the fifth. We are okay. I believe we're doing linear amount of work per test case, so it should be fine. Let me create two variables which are lower and upper boundaries of load. Yeah, so we maintain track of where can be the bottom of the current section. So initially it should start on the ground. Okay. Then we will iterate over, or actually we don't necessarily want, yeah. We will just iterate over heights of the ground like that. But we don't really want first element, we don't want to use it, okay. I know it's not really pleasant to have a loop that starts at 1, but whatever. When we encounter next element of the ground height, there can be several cases. So upper should get a max of next height plus k minus 1. Max is in algorithm, I believe. Also, max cannot increase more than k minus 1 from the previous. And I believe that's it. So this is how the upper possible position of the bottom end of the plank changes. Now we get to lower position. Or I should say mean of this term, I believe. Now lower, however, is max of ground level, right? We cannot drop more than k minus 1 units from the previous level. Is this it? I mean, is this it? It may be just it. I don't know. It feels a little bit too simple. And then we want to, if lower equals last element of the height array, then it is possible to build such a wall, else it's not possible. Let me test. I mean, it feels kind of a little bit too easy. So on the other hand, okay, not a big deal. Should be a colon, not a semicolon. Okay, not great, because in the last case, something is definitely wrong. We have 3 elements and we have planks of height 2. Let me check what happens in the last test case. So we have like ground level, right? I'm drawing ground level. Have 3 and 2 and 0. So initially, lower bound and upper bound are 3. Then we process the next element and we say the following. So upper cannot decrease more than 1. Well, upper also cannot be. No, it means that up here we have that upper cannot increase more than k minus 1. So at most 4. And also at most height level plus 1. So because there cannot be entire section here, so we have at most 1. Obviously, we choose 1. So upper is here. Okay. Clearly, we do not check upper against previous lower, right? I mean. Yeah. So this is a reasonable bound that does not depend from current upper and lower bounds, and we cannot drop that much. So we also need to create a Boolean variable which will denote how we ended the loop. If upper is greater. No, we just want to say that upper is also at most at least if upper is smaller than lower minus k plus 1, and I feel like we can check it afterwards. So if upper less than lower, broke equals true, and we break. Because what happens? Let me draw. Okay, so lower, right? Lower is at least 0, and also at least 3 minus 1, which is 2, because you cannot drop very quickly from the previous lowest position. We get a contradiction in between because lower is bigger than upper. And now we took care of this contradiction. Let's try again. Now it's yes, no. I'm not 100% sure in this version, but let's test it anyway. And it would be better if we wrote several test cases ourselves, and we will definitely do if it fails, but it gets accepted. Okay, we are not kind of slow, but it's okay. Well, let's try another one. So cell divisions. Yeah, and Do we have test? Yes, we again have test cases. I believe it's very convenient for Codeforces to have multiple test cases in one, because then they can run test cases faster. So we have an array and also have less input files. I mean, the size won't change, but the number of files decreases, which is good for navigation purposes. We have an array, and initially it's filled with integers from 1 to n. In one step, we can choose two indices and divide one by another and set the result to ceiling of the division. Okay. Our goal is to make array A consist of n minus 1 ones and 1 2 in no more than n plus 5 steps. Note that you don't have to minimize the number of steps. First line contains a single integer, and we want to output the sequence of pairs. Okay, so this is kind of a constructive problem where we want to construct such example. Let me take a short break and I will be right back because I want to eat something. I just woke up. Okay. All right, okay, I believe we are back. I had my coffee, right? We did not waste that much of time. Yeah, let's head on back to our problem. Yeah, so we want to reduce the array. But the problem is that we divide and we get as a sale, right? Ceiling, not great. Okay, what can we do? I mean, let's try. With n equals 2, we don't have to output anything. With n equals 3, we can divide 3 by... Well, actually, this is interesting. We can divide 3 by 2 twice, which will result into something like this. Whatever. All right. With 1, 2, 3, 4, what can we do? We can divide we can get rid of 3 entirely by dividing it by 4 immediately. And then we divide 4 by 2 times. Actually, this part is not very interesting. I mean, until something like 1, 2, 33. So if it's not 33 but 32, then we can just divide everything by 32. It will get to 1 immediately. And then we can divide 32 by 2 a couple of times. It's not all that interesting. Actually, how many operations do we have? N plus 5 operations, right? How many operations do we use? N minus 3 here. And then we have 8 operations to divide this value. In 8 operation is not enough. It means that we can, in such a manner, we can solve all test cases where n is at most 256. And after that, we have to think. I believe it can be easier if we divide everything that is not a power of 2. Like immediately divide it to until it becomes 1. Then we used a couple of operations and we remain with a sequence of powers of 2. And how many operations do we have left? If there are k numbers, then we used n minus k operations to get rid of the rest. So we have k plus 5 operations to deal with powers of 2. Or actually, we can leave numbers like 2, 4, 16, 256, and then 65,536. And there are exactly 5 of them, and I believe that there is a very good reason for that. Basically, each number is the square of the previous one. And what it means that you can divide each number by previous 2 times and get it to 1. Yeah, I believe that's it. That's it, guys. We solved the problem. So the point is that we take like sequence of squares. So we result into 2 to the first, 2 to the second, 2 to the fourth, 2 to the eighth, and 2 to the 16th. These guys, we don't check, we don't do anything to them. Everything else we divide by the largest element of the array. Then these guys we divide like follows. We divide last by pre-last 2 times, gain 2 times, gain 2 times. And that's how we do it, guys. We actually could, we are not using n plus 5 operations. N plus 5 operation would be enough for numbers of n up to the 10 to the 9th, but of course, because we have O of n output size, it's impossible to do it for larger values of n. Okay. Let me create a short array of integer of size 5 special numbers, which will contain the numbers we were talking about, not 8. 65,536. Am I correct? Let me check. We can always check. 256 times 256. Yeah, I was correct. We have a couple of special numbers. We will also like to have array header included. Now we do the following. For all numbers, we don't want to do anything with 1. It would be unnecessary. So for all numbers, if I want to check if the current number is not in special numbers. How do I do it? The array of find. Okay, it will be just, okay. Oh, actually, if I can simply, yeah, not the greatest name of all, but it will do for now. I believe that writing explicitly is faster than writing stp find and comparing with empty iterator, but I may be wrong. Okay, so if this number is not such, and we can't use this with the last number, unfortunately. Oh, that's why we need it. That's why we got 5 operations, because special number is also n. N is a special number. Well, we won't compare explicitly. Okay. So what do we do now? We output a line, something like I n. We can divide just by n. By this point, at most, we have the following numbers. Well, actually, now that I think about the special numbers, it makes perfect sense to me. We will use vector, and we will use algorithm. We will use if std find special numbers begin special numbers and I equals special numbers and oh, kind of close to line limit, but it's okay. So if we can't find current number in special numbers, and okay, let's start with 3 term. I would also like to sort special numbers, because who knows, maybe n is not the biggest element. I also don't want to insert n if it's already there. So let me do a quick check. All right, so now we have these numbers in sorted order. And what I think we will do is we want to divide last 2 times by pre-last, pre-last 2 times by pre-pre-last. So yeah, it's length equal. And we also want to remove all numbers from special numbers that are bigger than n. Okay, so pre-special numbers will also have special numbers. Pre-special number in pre-special numbers. If free special number less than or less than n, and special numbers push back free special number. Now we take the number of elements in special numbers, which is of course size. For index gets length. Index is at least 1, I believe. We decrement index and we do the following. We output special numbers at index. First is the one that we divide. Okay. We will divide twice by special numbers at index and at index -1. Okay. Just copy paste it for now. Let me think. We will never divide by greater than 0. I suppose it's greater than 0. Should be, right? Right. Oh, we shall also output the number of operations. What the heck? Oh, we actually know the number of operations, right? Number of operations is uh, 2 times length -1, because here we have 2 times length -1 operations. And also here we have n minus length operations, or not n, but n minus 1 minus length. And the reason is because we process all numbers from 2 to n, so a total of n minus 1 numbers, but we do not process special numbers. Sounds reasonable. Let's check it against. No, it's the output. I copied the output times 2. Apparently, we do not output something expected. I mean, where from this thing happens? Let me modify the code so that we know. So this is second. So second outputs. Oh, of course, I'm stupid, chat. I'm so stupid. Yeah, sure. That's the correct way to do it. I tried to, the problem was that I tried to access first past last element and it didn't fail because of no sanitizing, but it failed with wrong answer. We actually may now have the exact same output. Expect. Let's try. We may be where no, okay, accepted. Perfect. Kinda easy problem. A lot of people are already solved it. Let's try another one. Let's try another one. And another one. Another one. Okay. Can I? Okay, so we still have test cases, but the number of test cases is Q. Whatever. I don't mind. I can handle different variable names in consequent problems. I don't mind. It's okay. So we have the two strings, both of equal length k, and we define them to be a bit similar if they have same character in some position. Okay, so at least one position where the strings are equal and we are happy with it. Given binary string of length n, characters are zeros or ones, and integer k, okay, so we take substrings. Okay, okay. So we want to find lexicographically small string that is beautiful. That's it. A bit similar to every substring of length k of the original string. It sounds like another try problem, right? I guess. Or does it? Or does it? This is tricky actually. This one is tricky. My original thought was the following. Let me example. We can read input as I think about the problem. Oh, yeah. So my original idea, what the heck? I mean, why in the first problem, I'm 100% confident they allowed printing no in mixed case, and now they don't allow. Yeah, let me just do that so that you can see. I mean, here you can print anything you want, and there you can't. What is that? And you guys were preparing a contest why you cannot make problem statements be consistent. Also, a different letter for the number of queries for test cases. I don't understand. However, I mean, these guys prepare a lot of contests, so we got to respect their work. And yeah, I understand it might be difficult to prepare everything. Okay, so in the first problem, we have a string like this. We are interested in substrings of S2, which are 0, 1, 1, 1, and 1, 0. My original idea was to create a trie. But now that I think about it, I mean, trie should not work, and I mean at all, because it looks like it can have quadratic number of entries, which will be very sad. Right? And then I wanted to do something like, well, I would like to have one. So let me take one and then check if I can deal with the other part of the trie. This is tricky, actually. So we want all substrings of given length, and we want to find a string that is a bit similar to each and every one of them, and we also want to exit perfectly a larger substring. But I have no better idea about how to store that many strings, which are binary. This is strange. I mean, I believe trie can have quadratic number of nodes, and we can't allow anything quadratic. This is strange. Let's take a look at more examples. For 1001, have substrings like this, and like this. And we can't take 1 as the first element of our answer because these two will be bad. So we got to take 0 and then we got to take 0 again to satisfy this one. Wow. Very smart. Let me make it pause while I think, and I'll be right back.